Okay, so a lot of these images have if-then statements, so it'll make the theorem, the perpendicular bisector theorem, make more sense. So basically, if we have a perpendicular bisector, so I'm going to write this under the image. If we have a perpendicular bisector, meaning we have a line, so go ahead and draw this, with points A and B, and we have line L coming down and bisecting points A and B. Since it's a perpendicular bisector, it forms a right angle and two congruent segments. So if we have a perpendicular bisector, then this arrow actually means then, it's an if-then statement. So if we have a perpendicular bisector, then we're going to draw the same image that we just drew, and then we'll do something to it in a different color. So in the same color, I would draw exactly what we have on the left-hand side. Okay, so if we have that perpendicular bisector, then if we put any point anywhere on line L, so I could put it down low on line L, or I could go up high on line L. I'm going to put mine right here. It doesn't matter where we put it. We'll call that point P. If I put any point P on line L, then what we are saying is that AP is the same distance or same length as PB. So on the bottom, I'm also going to write that segment AP would be congruent to segment BP. Okay, so if we have, let's see, a line with a point anywhere on that line, that is equidistant to endpoints of a segment, so those congruent marks show that they're equal distance, the same length. Oops. Make sure we label A and B as well. I forgot to do that. So basically, if AP is congruent to BP, then we'll draw our same image again on the right-hand side. All right, so if we have AP is congruent to BP, then we have a perpendicular bisector, which means that line L is a perpendicular bisector. So we have a perpendicular, right? And it's actually on both sides because it's a linear pair, so you could draw it in on both sides if you want to. And then we also have congruent segments here because it bisected, it created two congruent segments. So therefore, line L, so remember this means then line L is a perpendicular bisector. Just remember that a perpendicular bisector has two pieces. It has the 90 degree for perpendicular, and bisector means two congruent segments. In this case, it's a segment. Sometimes it could be an angle. Okay, if we have an angle, we'll call it angle B, A. I shouldn't have put A right there. C. And then we have an angle bisector that we'll call line L, which means it's going to split angle ABC in half. So that's going to create two congruent angles right there. So the wording is, if we have an angle bisector, then, okay, so if we have an angle bisector, then we have, oops, bless you, it's okay. Then we have a point P that would be perpendicular. It's the shortest segment. So it's perpendicular. And it's also equidistant from point B, sorry, I put B in there. From point B to P and from C to P are also equidistant now. Okay, so we have, thank you. We have, I should have made these a different color because this is the then part. So I just wanted to adjust that, and I added in that was an angle bisector, so I had my congruent angle marks there. So what we have now is BP. So this is the then. BP is congruent to CP. For converse of the angle bisector theorem, we would have line L with angle BAC still. We do not yet know that it's an angle bisector, line L. We don't know that. But we do know that we have right angles and congruent segments here. So if we have that, same color. If we have two lines equidistant, okay, we're recording again, so we've got our right angles, our congruent segments. So our two images match now. Then, thank you. Then we have, let's see, line L is an angle bisector. So that means that we have two congruent angles, angle BAP and angle CAP, marked with the blue congruent angle marks there, the arc marks.